So in this problem, what you have is you've got a mass. It's connected over a pulley by a cord to another pulley. That pulley has two masses that are hanging on it. And I'm going to make one alteration to this diagram right here, which is we're going to erase this. Oh no, we're going to use white to do that, right? So we're going to go, and we're just going to erase this little piece right here because it's a little bit confusing. This is the acceleration of object 2, but we need to talk about what direction it's going to be. All right. So we know that we have these masses. We see the values of what they are right here. We're going to be using g equal to 10, and our goal is to find the acceleration of each object. Okay. The thing about this problem is that it handles relative accelerations, and we need to be able to think about how those are going to work right here. So if we look at this mass right here, and we think about what that symbol right there represents, A1, okay? This means frictionless. What does A1 really mean? What is that? That's the acceleration of the block relative to what? You can either type it, or you can also just say it if you want to cue your mic. Oh yeah, and this thing, is it scrolled all the way down? Yeah. Are you the only one? Oh, did I not start it yet? No. It's up. So Diana Silveira, you can... You're not even in my chat, are you? I think she's in the wrong chat. Okay, never mind. I don't see that person here, but... All right, so what is this going to be then? What do you guys think? What's this? The acceleration of the block relative to what? Am I able to hear anything you guys say, or is just no one talking? If you'd rather type it in chat, you can do that too. If I say that this block is accelerating, what do you think that acceleration is relative to? You want to take a guess? Oh, really? Thank you. All right, I'm very sorry about that. He says you have push chat on, and I was sure how to set that up, Matthew says, right? That was from today. For push to talk, what you have to do is you need to click on your user settings. You go in here, and after you click on this button, that's what you have to do. Okay, so I see Ash already answered the question. Thanks for noting that I wasn't on the right thing. So this is the acceleration of the block, not due to gravity, but it's the acceleration of the block relative to the ground or the Earth. So I'm going to label this as A1E. And then we're going to kind of identify what these other accelerations here represent. Okay, so you've got A2 right here, and you've got A3 right here. And we've also got a pulley. Okay, so we're going to label the pulley as P. Okay, and we're going to say the pulley is also going to be accelerating downwards with the same acceleration of A1. And I'm going to call this the acceleration of, well, it's the pulley, right? So the acceleration of the pulley relative to the Earth happens to also be the same as the acceleration of this guy. So it's equal to A1E. And let's talk about these two right here, and let's think about what's going on. So this acceleration and this acceleration, we can think about them in multiple different ways. One thing we could talk about is these two things. We could talk about the acceleration of block 2 relative to this pulley right here. That would be the acceleration of block 2, so mass m2, relative to the pulley. And then we'll define A3p to be the acceleration of m3 relative to the pulley. And then we're going to think about what's going on in the system right here, because if we isolate everything below the pulley, so that all we're looking at is basically a pulley with a mass here, and then another mass over here, and this is 3 and this is 2. If we look at the numbers right here, mass 3 is 10 and mass 2 is 5. So that means that in a vacuum, if this was our whole system, like if this was just attached to a ceiling or something like that, that mass 3 would go down this way and mass 2 would go up this way, right? And if it was attached to the ceiling, then whatever the acceleration of this block would be the same as the acceleration of this block. It's just that this one would be down and this one would be up, right? So can any of you tell me then, if I want to know what the relationship is between the acceleration of block 2 relative to the pulley and the acceleration of block 3 relative to the pulley, what's the relationship here going to be? Are they going to be the same, or are they going to be opposite to each other? What do you guys think? How are those two related to each other? What do you guys think? How will these be related to each other? Is this too hard? Am I jumping too deep into the problem? I'm not trying to go above your guys' heads. I just want to help you to understand how to solve stuff like this. I know this stuff's hard. Yeah, opposite because they're in opposite directions. That's right. So they should be negative. Yep, that's right. That's how they're related. One goes up, one goes down. Relative to the pulley, at least, right? This is in a vacuum where we're assuming that the block 3 goes down and block 2 goes up and the pulley stays in the same place, right? Now, if I now want to figure out what each of these A1, A2, and A3 are really going to, what we're really going to need to solve this problem is we're going to need to figure out what is the acceleration of block 2 relative to the Earth going to be. In order to figure out this, we can use our relative acceleration equation, which is similar to the relative velocity equation, which tells us that if I want to know what the acceleration of block 2 relative to the Earth is, then all I need to know is the acceleration of block 2 relative to some third object, in this case the pulley, and the acceleration of the pulley relative to the Earth as well. This will give me, if I add it together, the acceleration of block 2 relative to the Earth. The p's kind of, in a way, merge together and cancel, if you want to think about it like that. But this will tell me the acceleration of block 2 relative to the Earth. And we can also state, in the same way, that we can find the acceleration of block 3 relative to the Earth. That one's going to be equal to the acceleration of block 3 relative to the pulley plus the acceleration of the pulley relative to the Earth. Do these equations make sense? And do you guys have any questions? Another thing about push to talk is if you don't know how to do it, what you can do is you can just manually mute your mic, like here, and then just stay on open mic. You know, you can just click mute, no one can hear you, and you can take it off. So, all right. Do these two equations make sense to you guys before we do some math with them? So we're going to use this one too. with these. And what we're going to do is we're going to scroll down a little bit. So we know, I'll write this one over here because we're going to lose it in a second. So we know that a pulley, Earth, is also equal to the acceleration of block 1 relative to the Earth. So now what we're going to do is we're going to take these two equations here, and we're going to add them. Not that one above it, but just these two. This equation plus this equation. On the left-hand side, we're going to get a2e plus a3e. On the right-hand side, when I add this plus this, since they're equal and opposite to each other, they're going to add to 0. And then plus these two added together give me a PE, but APE is just A1E, so we could write this as A1E now. And then we can just state that, let's drop the E's, because now we have every single acceleration is in the same reference frame, which is really important for doing these kind of problems. All the accelerations are in the same reference frame. And that allows us to just say, okay, let's just call this one A sub 2, let's call this one A sub 3, and say that that's equal to 2 times A sub 1. And this is how you have to start this problem. You need to have this relationship kind of in your back pocket to be used later on. So did that line of logic make sense? And do you guys have any questions? Feel free to ask in voice. You don't have to type it, but if your voice thing isn't connected and you want to type it, that's also fine, because I'm looking at the chat. If you guys don't have any questions, then I'll keep going. So now what we need to do is to kind of analyze our system. And it might be a good idea to kind of zoom back out here a little bit and see what our system was. So that's the system we're dealing with, right? And maybe what we can do is we take what we've got right here, we'll copy this and go down just a little bit and put it again right here. And now what we want to do is we want to figure out what these accelerations are. And if you were trying to solve this and you didn't know what to do, what would you think to do? I mean, what's the next step going to be if I want to find out individually what each of those accelerations are? Where do you go next? Let me drag this over here. We can use all this space to write. What would you do next? What do you guys think? What would you do? I mean, it's problems like this. Like, you don't really know. Like, how do you get to the acceleration? What would you have to start analyzing to get to the acceleration in this system? What would you do next? Analyze the forces acting on each object, right? That's exactly right. That's what we always do in problems like this, is we just look at all the forces, right? That's right. So let's do that. We've got 3 objects, right? We've got M1. And let's label the forces acting on M1. Everything's kind of, no like trig in this problem, which is kind of nice, but doesn't mean it's easy. So on M1, we're going to have forces that are going to be the forces are going to be tension going this way. There's going to be a normal force that acts up this way. There's no, and then we got M1G pointing down, right? Those are the forces acting on M1. Acting on M2, we've got, let's come over here, this should be enough room. The forces on M2 What are those going to be? Actually, maybe we do the pulley too. Let's look at the pulley over here. And we'll just do like slightly smaller ink for this because it's kind of a... If we look at the pulley that's over here, if I call the tension in this rope right here to be T, that means the tension here is T. And the tension right here would be T2, right? Same tension at each pieces of this rope right here. And then on the opposite side of the pulley right here, you're also going to have forces going down like this and like this. But similar to the problem we did yesterday, what does the tension in the left-hand cord need to be right here? That is to say the tension that's going to be acting on M2. What would that tension be? Can anyone tell me what it would be if you look at this diagram here? What's the tension on M2 going to be? No, it's not that simple, A.B. Gomez, unfortunately. You have weight, and that's going to be there, but the tension's not going to be equal to the weight. We did a problem like this yesterday where we had pulleys that were going up, not yesterday, but 2 days ago. We had a pulley, and it had tension this way, and then it had two tensions going the other direction. What's the relationship between these tensions here? Yeah, they're the same, but do I need to label them? I need to label them something else so that you guys don't get so confused. So if I call this one, let's say T1, I would argue that this one would also be the same. That's correct. That's what Matthew just said. That's right. Opposite. Okay. How are these tensions, T1 and T1, related to this tension T then? They're half of it. There you go. That's right. The relationship has to be that T is going to be equal to basically 2T1, which means that T1 is equal to T over 2. So the upward force that's acting on this guy is going to be T over 2. If I can get this thing I figured out to work. It does work. Okay, so that's our forces on M2. Does anyone have any questions about that? The idea is that if the pulley is treated as all pulleys are perfect, which means they're basically frictionless and have no mass. So hope that makes sense to you guys. All right, the last one we have then is M3, and the forces on M3. Oh, I didn't make this very clear, but this is also T1, and that same T1 is going to be acting back up this way. So the forces acting on M3 are going to be just the same T over 2 going up, but going down you're going to have M3G. Do you guys have any questions about that? Those all look right? Next thing we need to do on all these diagrams is to label the acceleration. We'll choose black and we'll label it for all of these. The acceleration of block 1 is to the right, and we're calling it A1. The acceleration of block 2, it's kind of complicated. It could either be up or down, right? But I think you guys would all probably agree that since M3 is 10 and M2 is 5, that M3 almost certainly is going to go down. Would you guys agree with that statement? Does anyone have any objections to that statement? That makes sense, right? Like, is there any question in anyone's mind that there's a possibility that M3 over time would go upwards? You know what I mean? It's heavier than this one. So even if you go back to the system that we were looking at a second ago, this one here, if 3 is heavier than 2, then 3 goes down and 2 goes up. You guys all understand that, right? In addition, in this system, the pulley
right, the pulley has to go downwards because it has these two masses that are hanging on it. There's zero chance the pulley goes up. Would you guys all agree with that statement? There's no way the pulley's going to go upwards, right? All right, so what about M2, though? Would you guys agree that it's a little bit weird with M2? Like that you might think that it's possible that M2 may actually rise up while the system descends downwards? Right, do you guys, does that seem like the natural way to think about that? That maybe it's possible that M2 goes up? All right.
So I'm going to tell you that it doesn't. That relative to the ground, the M2 also has to descend downwards over time. And I'll try to show you later on how I know this, but I can tell you that if you make the assumption that it goes the other way, you're gonna have some problems. Your math won't quite work out quite right.
All right, so we can use these to generate equations, right?
Why don't you guys do it? Why don't you take like 2 minutes, and just to be 100% consistent here, we're gonna call this the positive x direction. We're going to call this the positive y direction for this one. We're going to call this the positive y direction for this one. And what I want for you guys to do is to write down your sum of forces equations, right? So for this one, it's going to be the sum of all forces acting on block 1 should be equal to M1, A1. For this one, it's going to be sum of all forces acting on M2 should be equal to M2 times A2. We're making the downward direction positive because that's what we have to do. The direction of the acceleration has to be positive. And for this one, it's going to be net force acting on M3 should be equal to M3A3. Now, these are not hard to write out, so I'm going to give you like a minute or two. Can you write the next line right here?
Write the next line of what happens in these equations. And I'll stop for a second, let you guys do that. Again, if you have questions, let me know. Did he stream on Tuesday? You're talking about me? Jason, I did. And there are VODs up. You can find them on YouTube. I will link you the YouTube channel right now. How do I think this is a link to my channel? I don't even know. I guess if I click no, I'll just link you the videos from, actually, you know what I'll link you? I'll link you the playlists that I made. So I made playlists to separate the 1C and the 1A classes. So this is the playlist, and I'm pretty sure if I click this, I can just link you. You can find the VODs of the lecture from Tuesday if you want to, Jason, there. So write the equations down that follow after these.
I hope that was enough time. This first one should be pretty simple. There's only one force acting in the same direction as the acceleration, so this one is just T is equal to M1A1. This one, we take down to be positive because that's the direction of the acceleration, so M2G minus T over 2 pointing up For this one, we take down positive, so it's going to look pretty similar, except it's M3G now, minus T over 2 is equal to M3A3. Okay?
I hope you guys were all able to get those same equations. And now it's just a matter of taking
all these equations that we have here. So basically, this one, and then the one that's circled in blue up there as well. We just need to combine those three equations together. Our goal is to find A1, A2, and A3. The total unknowns that we have are these. So basically A1 is an unknown, A2 is an unknown, A3 is an unknown, and the tension is also an unknown, right? So we have exactly 4 unknowns, and we have 4 equations here, right? All right. I'm really tempted to prove to you algebraically why this has to point down. But I think we'll come back and do that later on. With this accelerate. We'll do that at the end.
maybe off the camera, because, yeah.
So
now it's just a math problem. I hope you guys can see that. This literally has just become a math problem now, right? So all we have to do is we just have to take this equation and combine it together with the other equations we have. So I'm just going to drag it down here so we have it. We just need to take those 4 equations and just push them together somehow. And I think the way that I'll do it, because I think it's probably the easiest, is to note a couple things here. Since this tension is equal to M1A1, we can basically replace any of the tensions with M1A1, right? And then we can replace A2 plus A3 and replace it for A1 here, right? We know that A2 plus A3 is equal to 2A1, right? So what I'm going to do is, everywhere that there's a T, I'm going to put M1A1. So like here, this equation, this one's going to become, oh no, let's go to the thinner ink. Okay. This equation is going to become M2G minus M1A1 divided by 2. But I want to get A2 by itself, so I'm going to divide everything through by M2. So we'll divide this whole thing by 1 over M2 and say that's equal to A2. So that means that A2 is basically just going to be G minus so that's A2. For this one, we're going to say that we do the same thing, but now I don't want to skip a step. So it'll be 1 over M3, M3G, minus T, which was M1A1, divided by 2. Oh, I already divided the thing. So this is just A3 now. Which when we multiply 1 over M3 through this, we get G minus and then we apply this one. We know that A2 plus A3 is equal to 2A1, right? So we say this one plus this one equals 2A1, right? So we're basically just going to do this plus this equals, oh, that looks bad with that marker. I should not use that marker. We're going to say this one plus this one is equal to 2A1, right? So this plus this is going to be 2G minus, we have M1A1 multiplied by both of these terms. I think it's okay to do this. A1 multiplied by, this one has, okay, I'm not going to skip steps. I don't need to. We have an infinite amount of board space, so let's not do that. So it's minus, so it's G plus G is 2G, negative M1A1. Get to the bottom of my pad so it's hard to write this. And then minus this one. And all of that's equal to 2A1. And now I'm just going to point out that we knew that M1 was equal to M3 was equal to 10 kg. And I think M2 was equal to 5 kg. And I'll go back and check, but I'm pretty sure if you look at your notes, that's, yeah, M1 and M3 are 10, right? So we can kind of simplify this equation a little bit here. And so let's do that. So we're going to have 2G minus M1 over M2 would be equal to 10 over 5, which is 2, over 2. So this is minus A1. M1 over M3, M1 is equal to M3. So this one is going to become minus A1 divided by 2. And that's all equal to 2A1. I'll stop for a second. Are you guys still following along? Does anyone have any questions? Are A2 and A3 the same? Never mind, I see that they aren't now. Whoops. Yeah, they're not the same. A2 pulley, I'll go back just a second just to remind you. This here was the statement that the acceleration of block 2 relative to the pulley is the same as the negative of the acceleration of block 3 relative to the pulley. But A2 and A3 are definitely not the same. Yeah, you can see it within the equations here. Although for certain values, like if, well, just, yeah. Okay, so 2G minus A1 from this one, M1 over M2. Get my mouse to show this. M1 divided by M2 was basically 10 over 5. which is 2 over 2, so you get a 1. And then m1 over m3 is 10 over 10, so you get a1 over 2. That's equal to 2a1.
Okay. And we can just solve this for a1 now, right? So we end up getting what, like 2g is equal to, this is like 2 plus a half, so that's 2.5, plus 1, so 3.5, right? Or 7 over 2. Which means that a1 is equal to just divide 3.5 over here, multiply 2 over 2, and you get 4g over 7. And then we can use our other two equations up here to find a2 and a3. You should be able to prove that. If I plug in for a2 right here, a2 is equal to g minus m1 over m2 was 2, basically just 10 over 5, which is 2 over 2. So this is basically g minus a1. So a2 is going to be equal to 1 minus 4 sevenths is 3 over 7. G, that's what a2 is. And then for a3, that's our equation. And we have that a3 is equal to g minus, so m1 over m3 is a1 over a2. These are equal to each other. M1 and M3 are equal to each other. So this is going to be g minus a1 over 2. So that's 4 sevenths divided by 2 is 2 sevenths. So g minus 2 sevenths is going to be and that's the answer. Do you guys have any questions? I see I have a lot of private messages. I'll check those in a second when we're off. Oh, shoot. Did I make a mistake? Aha! Yes, he's correcting me that this should actually be... This was a3. Thank you. Yep. There's a lab manual problem like this. I haven't assigned it for you guys yet, but I may assign it later. I don't know. You guys have any questions? Okay, since we're done with that problem, I will stop recording for a second.